All right, so next up in our notes, we need to talk about gases. That gaseous state of matter. Again, we have a definition for gases. There's no definite shape or volume. So what that means is that gases expand to fill their containers. They take the shape of their containers. Right? They're made up of particles that are flying around really, really quickly. Right? Flying around until they hit the walls of their containers and bounce off and go in a different direction. Right? Collisions with the walls of that container produce a pressure. So really, the next couple slides, we're going to be talking about pressure specifically. And pressure is just a force applied to a given area. So I have to have some force applied over a given area. A common pressure unit that you might be familiar with would be PSI, right? Which actually stands for pounds per square inch. So I fill up my pickup tires to 35 PSI, right? If I fill up a bike tire, I'm probably going to need to go more like 40 PSI. Generally speaking, the smaller the tire, the bigger the pressure required to make the ride smooth, right? Huge tractor tires have very small pressures in them, like 4 or 5 PSI maybe. But otherwise, right, what I'm talking about is a pressure again. I have a pound of force applied over some area, square inch. So in my basketball that's inflated to a certain pressure, I have a certain number of pounds per square inch on that surface area, on the inside of that basketball, obviously. Now, PSI is a non-metric unit, so we're not really going to use that, but it's a good place to start because it's something that you're familiar with. So in chemistry, right, in our class, we're going to use pressures, and we're going to start with this atmospheric pressure, normal atmospheric pressure that's standardized at sea level and a temperature of 0 degrees Celsius. So as you can see, top right, I have this quote: "We live submerged at the bottom of an ocean of air, by Torricelli, a famous scientist who one of our pressure units is named after. But essentially, you have all this air above you, around you in our atmosphere, and it puts a pressure on you. You don't notice that pressure most of the time because it's typically constant. You only really notice it when it's changing. So when you're driving down the mountain and your ears pop, right, you know that there's a pressure difference. But our units for pressure, right, we're just going to start with that atmosphere, which is actually the most basic unit. And atmosphere, one atmosphere, generically, is standard pressure, right? But that standard pressure is equal to a similar pressure in other units. So we're going to convert a lot of pressures back and forth, right? So again, jumping back to that PSI, one atmosphere is equal to 14.7 pounds per square inch, right? So we're going to need lots of different units of pressure. That PSI is really just a reference point for us. We're not really going to use that very frequently, but we're going to use other ones, right? Because one atmosphere is also equal to 760 millimeters mercury. In fact, the first time pressure was measured, they used an inverted test tube filled with mercury, and the height of the mercury in that test tube gave us our first pressure measurement. And the guy who did that was the guy from that quote above, right? So we don't usually call it 760 millimeters mercury. We usually call it 760 torr, right, for Torricelli. There's also other units, right? Possibly someday you might see a kilopascal. We don't really use that in class very much, but one atmosphere is also equal to 101 kilopascals. So there's lots of different units that may pop up, but recognize that two of these units are actually the same thing. That 760, it doesn't really matter if it's millimeters mercury or torr, right? So I can just flip-flop the name millimeter mercury for torr. But we're going to need all these different units, and we need to know that all of these are equivalent to each other, and all of these are standard pressures, right? So I have this STP at the bottom of the page. If you see STP in a problem, that means that you're automatically going to use one of these pressure values from above, right? You could use 1 atmosphere if it's appropriate. You can use 760 torr if it's appropriate. But you're going to use one of those pressures because they are standard. But also, standard temperature, again, is going to be my 0 degrees Celsius right here. Now, we're not really going to use 0 degrees Celsius very frequently because a lot of the equations that we're going to work with here in the near future, I have to use Kelvin. So I'm actually probably going to think of 273 Kelvin for standard temperature because that's what 0 degrees Celsius is in Kelvin. So anytime you see that STP in a problem in the future, you have to use one of those pressure units from above and or 273 Kelvin. So you're going to see that pop up pretty frequently. You need to know those things.